right, so let's go ahead. What are some of the words that you could have used? What's some of the math vocabulary you could have used in your warm-up? Jacob, Lucas. Algorithm. Let's do a little popcorn, so no hands, just pop them out. Integer. Negative. Sum. Oh yeah, great one. Absolute value. If you don't have absolute value down, write it down. I want everyone to have absolute value. On the warm-up. Yep. That's a big one. I like the integer. Rational numbers. What's a rational number? Yeah, it's a number with a ratio, right? It's a number expressed in some sort of ratio, which could be, usually it's like A over B, right? So it could be 1/2, it could be 3 1/2. Okay? So those are rational numbers. Integer was already said. Any others? Number line. I like that one. Yeah. Greater than, less than, equal to. Algorithm. Boom. We talked about that yesterday. You guys get some good ones. So, that was what you need to have on your warm-up. 2, I want to go over this. There's a box on your reflection, mathematical reflection, that says math vocabulary. This box is worth a point. How do you get this box? Jojo, you're falling into that trap. Don't fall into the trap. Close that. You don't need it open. Remember, all that is like a psychological trap. Don't go there. Okay. Read the question and come up with vocab. So let's read. I'm going to read question 3. How you decide which 2 numbers are greater when one number is positive and one number is negative. Now, what do I need math vocabulary to answer that question? Talk to your tables. Negative. Okay, what else? What else do I need to answer that question?
Which one's greater?
Which one's greater? Greater would be a great vocab word. What? What else? What other vocab do I need to answer number 3? Maybe. Opposite. Ooh. Some. Okay. So, a couple words that I definitely need. So when I read question 3, Olivia, it has greater. I'm going to need to use greater in my response. It has positive, negative. I'm going to need to use that in my response. Rayanne said opposite. There's a big maybe positive, negative, right? We talked about those. Any other words? Okay. Please put these away. These are due when? Nice. Tomorrow. So please go ahead. Close your math binders. Remember, you've had Monday, Tuesday, Wednesday. I've given you 3 days. These are due tomorrow. Okay, next. Friday school. 9:30, 11:30. Anyone can show up. Some of you you'll be asked tomorrow. Whether or not, we'll see where we are. But hopefully not many. But if you do need to show up, show up. Next. Remember, when you're absent, whose responsibility?
Yours.
I'm going to compliment Marcus, because Marcus is already talking to me. He's going to be missing when? Tomorrow?
Thursday.
He's already talking to me about work. He's like, hey, what do I do? How do I do this? And I was like, okay, go to Google Classroom. Watch the video. I'm going to making one today. I'm going to make one tomorrow. Watch the video and get caught up. So when you come back on Monday, it's like you were here. But we'll be crying because we miss you. Hudson. They are all now no longer restricted. I've went and unrestricted them. So the thing, what Slide has done, is they've made, because a lot of kids were going to really inappropriate YouTube videos, and they were going to YouTube at inappropriate times, they've basically restricted YouTube completely. So the only way that you can go there now is if it's been approved by your teacher. So I'm approving my videos because I think I'm pretty good.
Or you can get on the
Yeah, Ellie's like, eh. I like it, Ellie. Got to be honest, right? You got to be honest. Yeah.
Why do they restrict almost all of Vandermeer's old music and then a bunch of 50 Cent music? Why?
Because.
Yeah, they restricted my music and I got
Right.
real mad.
Today, this is what I'd like you to do. I want you to read the learning target for today. This is the same learning target as yesterday. But wait a minute, Tanner. You're going to read this learning target, and I want you to incorporate algorithms into the learning target. Okay? And what does this mean to you? Go, talk to your tables. Turn. What does it mean? When thinking about algorithms, what does that mean?
You need to see which negative or positive is farther from zero.
And what is that going to give you?
That's going to give you the sum either if it is a negative or positive.
Nice. Okay, work together here. I like what you said. Huh? How does an algorithm help us do this?
Well, it would predict the sum.
Why? Right? Why? Let's not use that word bigger. What's the word? Greater's okay, but is it? It's called something value. Absolute value. When the absolute value, you got to put that in, is greater. Okay? All right. So, I'm going to combine a couple. Shag, what was the word that you used that's really key for this? Combining, not just value, absolute. Thank you, Olivia. Absolute value. Olivia to the rescue. So, it is absolute value. What does absolute value mean? Oliver? Absolute value is what?
Number?
What is absolute value? You got to know what absolute value is for this. Hudson, can you help him?
Something, yeah. An absolute value is a whole number.
Ooh, no. Clover.
It's the distance from a certain number to zero.
It's how far a number is from zero. So why does that matter? Yes, I was listening to Marcus. He was saying, depending on which number, whether it's positive or negative, if the positive is further from zero than the negative, what's my answer? Positive. If the negative is further from zero than the positive, what's my answer? Negative. That's how I can predict. Okay. Good job on your homework. We are going to go close your books. All you need in front of you is your notes. All right, so notes. Notes for today. Yeah, last class did a great job. When I write, what do you guys do?
Right.
You guys write. All right. And I will try to incorporate you more because I watched 2 of my videos and I feel like I'm doing too much talking. You guys need to do more talking. So, well, I need to get more views, right? So what a great way to get more views, right? Don't you laugh, Marcus. That's how I do it, man. No, I tell you, it's a great teaching tool. No, I don't. No, it's a great teaching tool for me, Clover. Don't laugh. No, but think about it. Think about it. If you watch yourself, does it give you a good idea of things that you could do better?
No.
Yeah, it does. It does. It helps me be, well, for me, it doesn't make me sad. It makes me a better teacher. Because I'm like, man, I got to stop doing that. I need to do more of this. Here we go. This is what I want you to do. Here I have a number sentence. I talked about math being a language and numbers mean something. Well, these numbers that I have here in A mean something. I'm going to create meaning for them. So Jojo, make sure you have this in front of you. So here is my meaning. You write when I write. I know that this is where I start. This is my change, and I'm going to label that n, because that's what we've been labeling the change. Variable n. When I write, you write. Then, this is what I'm ending with. So I know that in my story, I'm not going to tell you the change, because it's not here. I'll tell you after my story. So, because I have to create a number story, I had $50.
Wow.
Yeah, you got to write this. I bought a helmet. I bought a new bike helmet. I owed my mom $10. Okay? How much? How much was the helmet? This number story, question mark. This number story goes with this perfectly because I'm not supposed to tell you how much the helmet was. Because in the number story is blank, but I'm not telling you yet. I'm writing the number story that matches the number sentence.
It was $60.
Hold on.
Shh.
So, then after I answer or after I write this, the helmet was 60, which in this case is a negative 60.
That's not money, Dad.
Guys, come on. Because when I pay for something, that's money out of my pocket. I'm losing that money. So I paid $60, which is a negative value to me because I lost that money and I gained the helmet.
But it's positive value.
So this is what I'd like you to do. Your job right now is to do this, Emma. You need to read this number sentence. And again, when I write, you write. I am leaving the start. I don't know how much I start with. Now, you might look at this and know the value, but you're not going to say it because your number story is going to express what this number sentence says. And then I know I change by 40 and I end with 20. So, you get to create your own number sentence. But remember, you're not saying how much you start with. You are saying how much it changed by, and you are saying what you end with. So you're kind of following my model. Ready? Independent. Think of your own number story. I'm going to be coming around. Go. Independent. So what is this number story going to be? You can write it right down here. Ooh, I like that, Joey. Ooh, I like what Clover wrote. I owed someone money. I like that. She's not telling you how much money it is.
Can you make up what you want?
Yep. But it has to follow that number story, that number sentence. No. This is, if you say I had $40, that means how much you started with. That's the change. That's how much it changes by. That's not how much you start with. You know, I can see. You have, yeah, because it's blank, so you can't say how much you start with. I owed somebody, that's good. I owed my friend some money, right? Then you're not saying how much that is. That's perfect. Does that make sense?
Yeah.
Yeah. Awesome. Ooh, that's good too, Oliver. I like that. I like that. Hold on. I'll be over there in a second. You are a disturbed individual with that many kittens. And the fact that you started with -40 is kind of, or -20.
-40.
Good, and that's awesome. That's a really realistic one, Chad. Really good job. Super realistic. Okay, perfect. So, now, what happened? Something changed. That's where you owed, you're not saying how much, but now something changed, and you're going to end with that much. So figure out how to finish that. Okay, Chad, go ahead, read your number story. Or, yeah.
I was in debt. I gained $40 to pay off my debt. I now have $20.
That's awesome. So Chad's saying, hey, I was in debt. So the only thing I know about this is that it's a negative value. He's in debt. He got paid $40. What'd you do for $40?
Paid off my debt and had $20 left over.
And so you got paid $40 for cleaning cat litter.
Oh, paid off gather.
Yes. He went over and cleaned Marcus's house because he has something like 40 more kittens than he used to have.
I had 40 kittens.
So here we go. So the idea is I'm starting with a value that I don't know. Something happens to that value in the end, and then you can say, I started with -20. I already owed someone money. That's why I like what Shay was saying about owing money. That's very real. You owe people money all the time. That's a negative value. Let's go down here. I would like you to write this word, commutative property. I'm going to be talking about the commutative property over the next few weeks quite a bit.
I put commutative for one of my notepads.
Yeah, you got it out of the book. Awesome. So commutative property. Commutative property said this, Eli, make sure you get these notes. Yeah? Commutative property says this. If I take a number, and we'll call it A, and I add B to it, it's going to equal a number C. Whatever. Commutative property says I can take those and I can switch them around and take, guess what? It's going to equal the same thing. As long as I am adding, I can take numbers and I can add them in whatever order I want. I can take the last number and add it first, take the first number and add it last. Doesn't matter. Jojo. Okay, subtracting, that doesn't work. That's why the commutative property is awesome. Subtraction doesn't work, so you can't do this in subtraction. But I'm going to be teaching you something about subtraction that you can do to make it commutative, but not today. So I can take these numbers and I can switch them all around. So because of that, I can start adding, Oliver, at any point, Hudson. I'm going to pick these two. Why did I pick negative 20 and 20? Opposites. So they equal 0. Opposites equal 0, so I get rid of them. Now all I have is 17 and negative 10. Emma, I have negative 10. I have 10 red coins. I have 17 black coins. Do I have 10 red coins or the opposite in the 17? Yeah, there's 10 black coins that get canceled out. So how many black coins are left?
7.
Down here. Because it's commutative, I can do this. I can add any numbers I want in any order. So because it's commutative, I'm going to pick 25 and 5. Why would I pick 25 and 5? They're easy to add, right? Nice. Yeah, they're easy to add, so I get 30. Now I have negative 12 and negative 8.
Add those to negative 4.
I like adding negatives together because when you add negatives together, which way do you go? Left. They become more negative. That equals negative 20.
So you'll have negative
So
10 back.
now I have 30 black coins, 20 red coins. Are there 20 opposites in the 30?
Yes.
Yep. They get rid of. So if I get rid of 20 of the black, how many black are left?
10.
That is commutative property to a T. It does not matter. Whoa. It does not matter. It does not matter which numbers I add when I am adding all the way across. It's awesome. Addition is commutative and it makes it super easy. I can find numbers that add easy together, like 25 and 5, or I can find opposites and get rid of them. So addition is really nice. Today you're doing this, guys. Now I'm gonna give you guys a clear warning. And I've said this before, and it's going to take 30 seconds. I have 4 days to teach you math. We get about 54 minutes if we go from bell to bell, like boom, boom. Most schools get almost 20 minutes more a day. So listen.
Why?
If you talk about something unproductive other than math, you're going to owe the time. I only get so much time for math. I have 7 kids coming in. It's not a choice of mine. I need you to realize math time is math time. You want to talk about lunch, what you're going to do tonight? Fine. You're going to pay that time back. I'm going to take your time. I don't want to do it. Please. We need to get better at staying on math. Here we go. This is what we're doing. Turn over. You can get your books out. Turn over your papers. Let's get moving.
So, before math, I was talking to Miss Fisher, and I had something going on with her here, and she said, how do you know the objects?
Go at lunch. We're almost there. That's what I would do. I would go see the nurse at lunch. That'd be the best thing. You can continue on from yesterday, okay, but some of the numbers are a little bit different. I'm going to tell you, B3 is a challenge. If you don't know how to do it, skip it. Okay. Stay focused on math.
We don't have to do B3.
No, you can skip if you want.
No.
Yep. It's all right. No, I'm almost done.
What happened if you add a negative? Does that a thingy that you're talking about? It makes it go back to a negative.
It makes it a bigger negative.
Yeah, negative added to a negative. Look, is that up here? No, it's not on there, is it? Yeah, it is right here. A negative plus a negative equals an even a negative further from zero.
A greater negative farther from zero.
Yep. Okay. No, it says decide whether or not the expressions are equal. You can look. You can explain if they are or not by using the algorithm.
Okay, thank you.
I was thinking about like adding the fractions. Does it stay like 5 if you add it?
Well, let's look. Let's look. If I have a number, here's a number line. Here's 0. Let's say this is -8. And this is -8.3. Okay? All right. If I add 5 positive, I'm going to end up here. Right? Because whenever you add, you go to the right.
For a positive.
Okay? If I'm at 8.3 and I add 5,
You get 3.3.
there you go. See? It's going to bring me to here, which is -3.3. Okay?
I accidentally did B2.
That's fine. Does that help you understand that, though? Right? It's basically, it's this. I take a negative, that's further from 0, I add a positive, it stays negative. Right? It's not going to change.
I was just thinking about -1, -5.
Oh, it's a good one. Yeah, community property, right? Those are the algorithms. How are these algorithms represented here? Does that make sense? And why do they work?
I did that.
Yeah, that's all right.
Answering that yesterday.
Because it says, decide your algorithm for adding integers from question A. This is integers. Right? Whole numbers and opposites, right? So, we know from that adding integers, it doesn't change. So, is it going to be different? -8 plus +5 is -3. What's this answer?
Oh, yes, it would work with fractions.
It does work with fractions. Yep. And you have to it just says, you got to say why. Explain. Okay? Explain why. That's where you would use the algorithm to help you explain. Or a number line.
Does your algorithm for integer A?
Yeah? You need help or no?
For this, do you just explain words?
Decide whether or not the expressions are equal. Yep. Are they equal or not and why? Okay? And that's where, Eli, if you use the algorithms, super easy to explain.
What are integers?
Integers are whole numbers and their opposites. So these are integers. And we decided that if I have two positives,
Yeah.
it's the same. If I have two negatives, it's the same answer except the answer is negative. But over here, if I have a positive and a negative, and I switch the signs on those two numbers, I get the opposite value. This is a -6, that's a +6. So does it work with rational numbers? That's the question. Right? We know it works with integers, but does it work with rational numbers? Do those algorithms work with rational numbers? Unproductive. Fill that in.
I'm confused on number 2 because no, I got it now.
Is
thought that
this-
was just 3? But it said that's 30.
Are you good?
Because it's -55. Yeah. Wait, which question? Which question? Because this is why. I told you. No, I'm gonna see if we can do this. And you don't.
guys need help? Raise your hand. Check your work. I've already seen Gavin go over and check his work. Ooh, wait a minute. If that's a negative 8.35 and that's a positive 5, what's my answer going to be? Why? In absolute value. It's further from 0, right? Okay, good. Yeah, Marcus? Oh, hold on. All right, guys, please put your stuff away. We're moving ahead. We got to do this quick because we're almost out of time. I want to give you plenty of time. Yeah. Homework for tonight. Get those planners out. Get moving. Today is September 11th. Here's your homework for your planner. September 11th, you want to write down 31 through 36. They're all adding positive and negatives. Very straightforward, but some good practice. 31 through 36, page 46. Page 46. 31 through 36 on page 46. Here's the exit ticket.
My dad can actually help because he's doing that.
Exit ticket. Explain with words an algorithm. Okay? Explain with words and an algorithm, something that is true about adding. Now, you don't even need the rational numbers because we know that whether it's an integer or rational number, if it's adding, things are going to be true. You can use these. What do we know about adding? What's true about adding?
It makes things bigger.
Not necessarily. Not necessarily. Yes.
You could change the two numbers.
I can add in any order I want. That's a huge thing. You can add in any order. Now, the only thing you have to do now is give me a couple algorithms that show me that that is true. You need to find the algorithms that are switched, that show you I got a large negative plus a small positive in absolute value terms equals a small negative. If I flip those, like here, small positive plus a large negative gives me the same answer. All right, guys. We have recess. Okay? So, make sure you do a good